Justify the placement of oxygen, sulfur, selenium, tellurium and polonium in the same group of periodic table in terms of electronic configuration, oxidation state and hydride formation. This seems to be a very interesting question. They're trying to ask, why are they in the same family? That means they should show the same trend in properties. There should be some generic commonality. And this is what we are supposed to bring out in terms of these three things. So first, let us take a look at electronic configurations. Let me remind you, oxygen, sulfur, selenium, tellurium and polonium, all these elements together are called chalcogens. Fine. Now, they have 6 valence electrons. That means the general electronic configuration is NS2, NP4. So, oxygen is 2s2, 2p4. Sulfur is 3s2, 3p4. Likewise, polonium would be 6s2, 6p4. Okay. So, this N varies from 2 to 6 and you have oxygen, sulfur, selenium, tellurium and polonium. Oxygen and sulfur are nonmetals. Selenium and tellurium are metalloids and polonium is a metal. Is that significant? Very significant. They have a number of different oxidation states, -2 being the lowest. Oxygen loves to stay in -2. Sulfur, selenium and tellurium can visit -2. They can remain in -2. Yes, polonium is a metal and polonium hardly shows -2. That minus is here, 2 is here. Don't get confused. So polonium, actually for all practical purposes, polonium would not exhibit a -2 state at all. Right? Now, oxygen, does it show positive states? Oxygen can be a maximum of +2 and that also only with fluorine. The oxygen forms OF2 or O2F2 in which oxygen can show +1 and +2, but that is rare. Otherwise, oxygen is always negative. Sulfur, selenium, tellurium and polonium, they very well can go to a higher state of +6. So yes, they can go to +6 and they can also exhibit +4 and rarely, like sulfur, can also give you +1 and +2 states, but that is not the trend for selenium and tellurium, so let's skip that. So they can show +6, +4 and -2. A rarer state of +2 but not very popular. And again, these higher states of +4 and +6 are not shown by oxygen. This, my dears, is a common trend down the group when it comes to oxidation states of chalcogens. Hydride formation also is very interesting. They always have H2E, like H2O, H2S, H2SE, H2TE. H2PO is very unstable. Polonium is a metal. The polonium does not form hydrides. So we have oxygen, sulfur, the nonmetals, selenium, tellurium, the metalloids. All of them can form this H2E. That means a hydride which contains 2 hydrogen. If you move down the group, you find that hydrides become less stable. So yes, you find bond length increases for H element bond. Bond strength decreases, reducing power increases, HEH bond angle also decreases and basic strength also decreases on moving down the group for H2E in general. These are the properties.